Okay, let's just jump right in. What if I told you that everything you think you know about physics, particles, forces, even space and time itself, what if it's all built on a shaky foundation? That's the wild idea behind something called single point theory. It's this fascinating, kind of speculative new framework that says, hey, maybe all of reality, literally everything, boils down to one single repeating process. It's a pretty radical vision of the universe, so let's dive in and see what it's all about. So, the whole thing kicks off by attacking, well, our words. The theory basically says the word particle is the root of the problem. Think about it, right? For centuries, we've pictured these fundamental things as tiny little billiard balls. But then, to make that metaphor actually work, we had to keep inventing stranger and stranger rules, like wave-particle duality, just to explain why our little billiard balls sometimes act like spread-out waves. Single-point theory argues that that's the original sin of modern physics. We started with the wrong picture, the wrong metaphor from day one. All right, so the trouble with physics. And yeah, this flawed starting point is really just a symptom of what the folks behind this theory call a deep-seated malaise in physics. I mean, look at the Standard Model. For all its amazing successes, it's incredibly complex. It's got this whole zoo of different particles and forces that are basically just plugged in by hand. They're not derived from some simpler, more fundamental principle. It's kind of like trying to understand a car by starting with a list of all its parts, instead of first understanding how the engine works. So you can really think of this as a tale of two different starting lines. On one side, you've got our current model. It starts with this huge, complex shopping list of ingredients. You need a bunch of different forces, a whole host of fundamental particles, and hey, why not toss in some extra dimensions for good measure? But then on the other side, you have the radical proposal from single point theory. It just asks a very simple question. What if we start with just one thing, a single, simple, repeating process, and then just see if all that complexity we observe just falls out of it naturally? Okay, so a radically simple idea. And this is really the heart of it all. The theory proposes that all of reality is generated by a single primary cycle. You can think of it like a tick of the universe's clock. And this clock is ticking at what's called the Planck frequency, which is the fastest possible speed anything can happen in our universe. We're talking 10 to the 43 times per second. That number is so huge, it's almost impossible to wrap your head around. And the idea is that everything we see, from an atom to a galaxy, is just an emergent consequence of this one single relentless process. So you're probably asking, how on earth do you get a whole universe from a single tick? Well, let's walk through the core axioms, kind of like a recipe. Step 1. You have that fundamental cycle, the universal clock, just ticking away. Step 2. With every single tick, a tiny seed of randomness gets tossed in, just a simple high or low bias. Step 3. The interference between all these countless random seeds naturally gives rise to waves. And then step 4, and this is the absolute key. When those waves interfere in just the right way, they create stable, resonant patterns. And those persistent patterns, well, that's what we call matter. And this leads to a really profound shift in perspective. If particles are just stable resonance patterns, then that old billiard ball metaphor, it's out. The new, better metaphor is a vortex, like a stable whirlpool you'd see in a river. We're moving from a universe of solid objects to a universe of persistent patterns in a single underlying field. This new metaphor acts like a Rosetta Stone for physics, letting us translate our old familiar concepts into this new language. So what we used to call mass, in this new view, that's just the energy density that's concentrated in the core of a vortex. Charge becomes a topological property, kind of like the direction a vortex is winding, clockwise or counterclockwise. And even force is simply the gradient or the slope in the underlying field that tells other vortices which way to move. So this is the fundamental shift in thinking, right here. On the left, you've got the old model, these little solid balls bouncing around. But on the right, you have the SBT vision, a dynamic field of waves, where stable, swirling vortices emerge and interact. It's a total change from a world of things to a world of processes. And getting your head around that conceptual leap is the key to the whole theory. Now, I know this all might sound incredibly abstract, right? So to make this a bit more concrete, let's connect it to a surprising real-world application, Nikola Tesla's AC motor. So from the perspective of single-point theory, Tesla wasn't just pushing electrons through wires. He was a master of orchestrating waves in the process field itself. An AC motor is seen as a large-scale interference engine. The coils create a rotating torsion pattern, basically a helical vortex in the field, and the rotor just locks into that pattern because it's trying to find its lowest energy state. It's torque from geometry, not just from force. And here's the payoff. By designing an electric motor from these first principles, by managing phase coherence and interference patterns instead of just pushing current around, the theory suggests we could break past our current efficiency limits. Instead of topping out around 97%, motors could potentially reach efficiencies greater than 99%. That is a huge leap forward. The ambition of this theory isn't just limited to motors, though. It aims to provide a unified language to describe physics at every single scale, from the inner workings of an atom all the way up to the fusion furnaces inside stars. Let's take stars. We know they shine because of nuclear fusion, where mass is converted into energy according to E=mc². In SPT, this process gets reframed. It's not that mass is destroyed, it's that the vortex configuration of 4 protons is just less stable. It has a higher total field energy than the vortex configuration of a helium nucleus. Fusion is simply the process of these vortices reconfiguring into a more stable, lower energy pattern, and they release the difference as radiation. And as you can see, the theory's calculations align precisely with the observed energy output. And the same logic applies to atoms. You know how an electron can only exist in specific energy levels? That's not some arbitrary quantum rule here. It's a condition of stability. An atom is a stable, resonant interference pattern, a kind of harmony among the proton and electron vortices. So quantization isn't some rule you just add on. It's an emergent property of which harmonies are stable and which ones aren't. So, look, this is a beautiful and coherent story, but is it science? A scientific theory has to be more than just a good story. It has to make specific, measurable predictions that you can actually prove wrong. And this is where SPT really steps up to the plate. This is where the theory becomes truly scientific. It makes several unique, falsifiable predictions that are different from the standard model. For example, it predicts that the Lamb shift, this tiny energy fluctuation in atoms, will scale differently with atomic number than standard quantum theory predicts. It also predicts a measurable enhancement when atoms interact with twisted light. These aren't just philosophical points. They're questions that can be answered in a lab today. And that's why this isn't a closed book. The theory's proponents are actively seeking collaboration with experts in a whole range of fields. They need atomic spectroscopists to run the experiments, mathematicians to formalize the topological rules of these vortices, and quantum gravity experts to help connect the dots. This is really an open invitation to the scientific community. So we'll end with this one, provocative thought. Single-point theory asks us to fundamentally reimagine our place in the cosmos. It suggests that the universe isn't a collection of separate things at all, but a single vast interference pattern, and that we, along with every star and every atom, are just resonant knots in that fabric, able to perceive only the vibrations that our own tiny threads can touch. It's a radical, beautiful, and most importantly, a testable new vision of reality.